everyone, today we are going to be comparing simple interest and compound interest. So if you look at the graph here at the front, the simple interest is a linear growth where compound interest is exponential growth. So let's take a look at some examples. Okay, so we're going to fill in the blanks here. Simple interest is calculated by applying the interest rate only to the original principal amount, resulting in linear growth. Simple interest is calculated using the formula I equals PRT. And we can make a little triangle that can help us with our formula here. So I is going to go at the top, PRT at the bottom. So if we're looking for the interest rate, we cover that up, and then the interest is equal to P times R times T. If we're looking for the principal, we cover up the P, and the answer for P would be P is equal to I divided by R times T, and so on. Okay, so let's define these variables here. So I is the interest earned. P is the principal. R is the interest rate as a decimal. And T is time in years. Compound interest, on the other hand, is calculated by applying the interest rate to the principal and any accumulated interest, and this results in exponential growth. All right, so let's take a look here at our first example. So we're going to compare. So Adam wants to invest $500 at a rate of 5% interest per year for 6 years. What will the value of his investment be if calculated with A, simple interest, B, compound interest? Okay, so to help us answer this, we're going to fill in this little table here. So simple interest, we know the formula is I is equal to PRT. So I like to write a little list of my variables and fill in everything I know. So we're looking for the interest rate, so I'm going to put a question mark there. You can put an X or whatever variable you'd like. P, the principal was $500 to be invested. The rate was 5%, so we need to convert that to a decimal, so divide by 100, 0.05. And then the time was 6 years. So if we substitute that into our formula, we get 500 times 0.05 times 6, and that gives us our interest is $150. So in total, the 500 plus the 150, I'm running out of space here, I'll write it up here. So 500 plus 150 is going to give us our total amount, including our investment, so $650. Okay, so therefore, the investment is $650. Okay, so next we're going to look at this little table here. So my year one, the principal is 500. Our interest, so if I plug in 500 times 0.05 times 1, we're going to get $25. Okay, so that total amount now is 500 plus 25 for $525. Okay, next, that 525 is going to go in as the principal for year two. So 525 times 0.05 times 1 is 26.25. Then we get 551.25. So now that 551.25 goes in the principal for year three, and that interest rate, so 551.25 times 0.05 times 1 is 27.56. Add that together, we get 578.81, and so on. Okay, so we get $28.94 for interest in year four, $607.75. So now that's the principal in year 5. So $30.39 is our interest for year 5, $638.14. And now that goes as the principal for year 6. So we get $31.91, 670.05. Okay, so there's got to be an easier way. So instead of making the chart every time, there is a formula, and we're going to be looking at that next. So we can see if we actually compare the two here with compound interest, we make $20.05 more than if we were just investing with simple interest. Okay, next, with compound interest, you earn interest faster because you calculate interest on interest. Okay, so let's look at our future value formula. So the formula to calculate future value of an investment that earns compound interest is A equals P times 1 plus I to the exponent n. So A is the accumulated amount, or the future value. P is the principal or original amount. I is the interest rate per compounding period. As a decimal. Okay, and then n is the number of compounding periods. Okay, so let's look at compounding periods here. So a compounding period is the period over which interest is earned. You can have different compounding periods. So annual means once a year. So whatever your I is, it's unchanged. So think about our previous example. So 0.05 didn't change. And n is whatever the number of years are in the example. So for example, 6, like our previous example. Semi-annual, on the other hand, is 2 times per year. So for the interest rate, we're going to divide by 2. For the number of compounding periods, we are going to multiply by 2. Quarterly is 4 times per year, so we would divide by 4 and then multiply by 4 for the n value. Monthly is 12 times per year, so divide by 12 or multiply by 12. Weekly is 52 times per year, and then we're going to divide by 52 or multiply by 52. And then last but not least, daily is 365, so divide by 365 or multiplied by 365. All right, so let's look at an example here. How much will Alana have in 15 years if she invests $2,000 at 4.5% compounded semi-annually? So I like to start by writing a list of everything, all the variables rather. So A, P, I, N, a pin. Okay, so A is what we're looking for, so I'm going to put a question mark there. The original amount, or the principal, is $2,000. The interest rate as a decimal, so we divide by 100, 0.045. Compounded semi-annually, so I have to divide that by 2. And the n is 15 times 2, which equals 30. Okay, so substituting into our formula, A equals P times 1 plus I to the exponent n. So A is equal to 2,000 times 1 plus 0.045 divided by 2 to the exponent 30. So just practice with your calculator. So on my calculator, I work inside the brackets first. So I plug in 0.045, divide by 2, get that answer, add 1, get that answer, take the exponent of 30, press equal to get that answer, and then multiply by 2,000. And you should get $3,898.79. So therefore, Alana will have $3,898.79. Okay. Okay, we'll look at one more example here. What is the value of an investment of $6,000 at 6% compounded monthly for 5 years? So APIN. So A is what we're looking for. 6,000 is the original amount. 0.06 divided by 12 and 5 times 12, which is 60. Okay, so plugging in, A is equal to 6,000 times 1 plus 0.06 divided by 12 to the exponent 60. Okay, once you plug that into your calculator, $8,093.10. Okay, so therefore the value of the investment after 5 years is $8,093.10. How much interest was earned? So if we take that amount and we subtract our original principal, we're going to get our final interest earned. So I equals A minus P. So I equals $8,093.10 minus 6,000. So I is equal to $2,093.10. Okay, so therefore the interest earned was $2,093.10. Okay, that's it for today.